All right, so we're going to look at 2.2a, not in direct order. Again, this correlates to the online textbook, and it also correlates to the homework assignment. So that's where those codes are coming from. Did anyone look at their online textbook yet? That's fine. You don't have to unless you need to. All right, so we're going to look at solving equations. Pretty much what you've been doing the last 100 years. Okay. I am going to throw in some more why things work than what you would have gotten earlier, and some more vocab things that are going to come up later. So for years we've asked, what is the solution? What is a solution? Well, this marker doesn't really work. What is a solution? Like, what does it mean to be a solution to a math problem? If I mix salt and water, is it a solution? Yeah, but that's not what we're talking about. What is the solution for math? It is pretty much it's any numbers that make an equation true. All right. So today we're going to deal more with like basic equations that you guys have dealt with. There's one solution, right? Or infinite or no solutions. Make sure you guys note this. The biggest question I've gotten on the online course so far is if there's no solution or infinite solutions, what to put down, and I will give that to you. So any set of numbers that make it true. All right. So whenever we ask for a solution, there could be multiple, there could be one, just anything that makes the equation true. The other question I'm going to ask, what does it mean to be linear? What is a linear equation? Oh, and just so you guys know as well, and this is for anyone else watching this, these lectures are shortened versions of the online lectures already posted. So if there is some lecture that I go through and you want more examples, if you go online, Dr. Webster from Mid-Mich has made longer videos that go more in depth and give more examples. So like I said, if you didn't get it the first time, there are more examples on there, and they all follow along the textbook. All right, so what is a linear equation? What's it mean to be linear? What do you guys think? What's something that makes something linear? It's a line. Thank you. That's it. It makes a line. Okay? It's a line, and we write it as ax plus b equals 0. That is like the common term for it because quadratics are written that way, quartics are written that way, trinomials. Now, we've also seen this as equals y, right? But I'm getting used to some different notation that we're going to see. Okay? Now, a and b cannot be 0. Because if either one's 0, it's not a linear equation. Well, maybe I disagree. It's from the book. I won't get into theory. All right, anything too scary so far? All right, good. That's really the brief notes. Again, if you want more, watch the other online video. All right, I'm going to jump right to it then, just do some examples. Sound good? All right. 4x minus 19 equals 5. I want to find the solution. So I'm looking for what number can I plug into this to make it true. All right. So I'm going to tell you, many of you guys are probably looking at this saying like, okay, I know how to do this, Mr. O'Leary. But just the steps we use for this, we're going to use for any sort of problem we're going to see throughout the year. Like, keep that in the back of your head, because whenever you're solving an equation, you have to keep it balanced. I don't care if it's a quadratic. I don't care if it's a conic. I don't care if it's a trig function. You have to keep it balanced on both sides. So if you can do this, you're going to be able to do any of the things we do this year because it's always the same idea. Because I know we've been going, like we go quick, but you guys know how to do this. For you to add 19 to both sides. Because what I can do anything I want to an equation to solve it, as long as whatever I do to the left side, I do to the right side, right? You can do anything. I can square root it. I can do inverse trig functions. But whatever I do to the left side, I got to do the right side. And if I keep doing that, I'll be okay. I'll be okay. As long as I'm trying to get that x by itself. So anything I do to this side, I do to the other side. Yeah, x equals 6. Now, what if I had a question? Test if x equals 6 is the solution to the equation. What do you think you do to test if that is a solution? You just plug it. Yeah, you plug it in. Nice job, guys. Nice job, team. And it works. And the college algebra team. One team. All right. Good. Now I'm amped. All right. We're almost done with the first page. All right, just a quick review then. We're just going to do a few more examples, find the solution. Highly suggest when you're doing your online homework or test, plug it back in, make sure it works. Just it'll save you probably 1 or 2 problems a year, and it's well worth it because it doesn't take very long. Now this is where sometimes we have some hiccups. All right, before I start solving this, what do I always have to do first? Always, and again, this is going to hold true. The reason why we're doing this will hold true when things get a little bit crazy. We're always going to want to simplify first. We're going to simplify and then balance. That's what I always say. Where we do the thing to both sides. So to simplify this, first thing I would do is the good old distributive property. Get 6x plus 24 minus 5 equals x plus 34. Is it simple? Not yet. Not yet. Combine my like terms. Now I can actually start solving it. Later in the year, we'll have some problems where your main goal is actually always to get it equal to 0. In fact, that's a really common thing in math is to try to get an equation equal to 0. So I'm going to subtract. Now watch this. I'm going to get wild here. Now when I'm solving this, can I actually do 2 steps in one? Yeah, because am I doing the same thing to both sides? 100%. So are you allowed to do that? Yeah, as long as you do it to both sides. That goes away. You get 5x equals 25, right? Oh, Jiminy Crickets. Math is tough, guys. All right, now what do I do to both sides? Divide by 5. There we go. All right. Anything too scary yet? Would you guys like to see more with simplifying first, or can I show you, or do you guys want to get onto like the new type of problem you're going to see? What do you guys want? The new. All right. Again, if you need more of these, by all means, don't be afraid to ask. I shouldn't say new. I'm going to give you one that's older, and I'm going to translate that into a problem that is more of a struggle. I'm going to teach you guys 2 different ways to solve these, and keep in the back of your mind, especially when we get to some later sections. All right. So x is on the bottom. Not afraid yet. I still need to isolate this part. I'm going to subtract 9 from both sides. Keep it balanced. You don't want to teeter, totter, and fall. All right. Now this is where I don't know if any of y'all had me for geometry, remember when the trig function or the x was on the bottom, that was always number one missed one. Or just when you see this, it kind of freaks people out a little bit. Now there's going to be two ways you can solve this. Okay, I'm going to give you both. So method one, I'm going to call the actual algebra method. X is on the bottom, right? That means nothing to me. How can I get x not on the bottom? What can I do to both sides? Yeah, exactly. Thank you. Multiply both sides by x, right? Multiply by x, and then you just divide by -5. That's not too bad, right? Now, could I have also seen it as a cross multiplication problem? Yeah. Could I? No, don't do that. Could I found a common denominator and then set them equal? Yeah. The other way, I do want you guys to put in the back of your head, if you do plan on going hours in math, it saves you a ton of time. I don't think this way is in the book on the video. So there's there's a thing with ratios that if two ratios are congruent, you can switch across and it keeps the ratios equal. I think I tried to show you guys this with trig functions back in the day. So I can just switch those. I can say 5 over -5 equals x. Okay? So anytime you have an x on the bottom equal to a number, you can just switch them. It'll work 100% of the time.
I got a question.
Yeah.
What if there's, you do the same thing if it's like 5 divided by x or 4x or?
Yeah, that would work. It does. What I could put.
So you divide into 4, do or leave the 4. Get rid of that.
Here, I'll show you. I'll give you another example. That's a really good question. Like, are you saying like, what if I had 2 over 2x plus 4 equals 8, right?
Yeah.
Works because it's still the ratio.
No, I'm talking about for method 1.
Oh, that'll work as well. Just multiply both sides by. Just make sure you put it in parentheses. You know what I mean? That'll always work. Yeah. Like either of the methods? Always. It'll always work. That's actually a mathematical like formula. It's if you guys want it's if you have a over b equals c over d, you can switch out either part always. So like a over c equals b over d. Like adding, subtracting, and such. You could, but there'd be no point to it. Like if there's variables. So this is really good questions, guys. So like if I had 5 over x plus 1 equals 3x minus 2, could I switch those? Yeah, but it's not going to get you anywhere. You know what I'm saying? So the shortcut's only really good if you just have one variable. If you have multiple, you're gonna do the multiply way, like multiply both sides, get rid of it. And then if you had, which I think if you had something like this, you would have to cross multiply and solve then. I don't think you have any of those yet. We're gonna be dealing with that later. Not yet. Not yet. Good questions. Good questions. Oh, just so y'all know too, because I'm posting this, I don't use your name, so I feel bad. I want to be like, good job, this person. Maybe I'll make nicknames up for you guys. Write down what nickname you want. That's school appropriate. All right. So that gets us to the wild one. Now, you've probably seen these before, but like I said, this is even something every year I have to remind myself how to do it. What if you get a problem like this? Well, that's. All right. So on this one, I have 3 distinct fractions. I can't do any tricks. It's not just a fraction equals a fraction, right? So I'm going to look at it for a while, and then I'm going to go to ChatGPT and see if I know how to plug in fractions and see if it can do it. You know, even before ChatGPT, there's something called Wolfram Alpha that would do the same thing. That was around since I've been in college. It was like an AI thing that did math and tell you the steps. Ah, good old Wolfram. So this means nothing to me right now. Like I can't solve it. But back in the day, if I gave you what's 1/2 plus 3/5, what do you have to do? What's your first step? Yeah, find the common denominator. Find a calculator. No. So I'd multiply by what? 5/5 and 2/2, right? And when I got done, I'd have the same bottom. Because once I have the same bottom, now I can actually add them, right? Same thing is true here, right? I can't do anything to this until I have a common denominator. Now I have a 2x, a 4, and an x. If you ever get stuck and you can't think of a common denominator, your worst case scenario would be to multiply all these things together. But now if I did that, I'd get, what, 8x squared? I don't want to deal with any squares. So I'm going to think about it for a second. What's the term? Least common multiple of these three things. Like what's the smallest thing I multiply by to make them all equal? So what does this have that this doesn't have? This one has an x and this one doesn't. What else? This is a 2 and this is a 4. Is there a way I can get 2 to 4? Can I multiply by anything? Yeah. We'll multiply this one by 2/2. One of these markers has to work. Now, why can't I multiply by 2/2 and it doesn't affect the problem? 2/2 is 1. Yeah, it's just 1. I'm not changing anything. My boss offered me a 1 times my salary raise. That's not very good. Now, that would make this 8/4x, right? Is there a way I can make this one look like 4x on the bottom? Yeah, multiply by x. X over x. So I get 2x/4x. And then what's this one missing? The 4. I multiply by 4/4. Now that I have all my bottoms 4x, what can I do with them? You can combine all your stuff, right? Here's what I always do. This is a different, I always just say once all the bottoms are the same, they don't matter to the equation until the end. So I can just do 8 plus 2x equals 20, right? Once all the bottoms are the same, set the tops equal to each other. And that's just like what we did before, right? So I'm going to go a little bit quicker on it. So I get 2x equals 12 and x equals 6, right? Now, one thing I have to keep in mind that we're kind of introing now is, does 6x work in the original equation? Like, does it make my bottom 0 to plug in 6? No. So it works. What would happen if I got like 0 for x? Does that mean this has a real solution? No, because you can't actually plug it into over 4x. All right. Again, we're going to go into that in a lot more detail when we actually get to the rational function thing. You do have one. Would you guys like to see another one of these? Because there is one on the homework that is very similar to it. Yeah, let's do one more. I don't think there's any that deal with like complex ones yet. Let's do one more. Let's say I had 1/5x. Ooh, that'd be difficult. Plus 2/x. This is probably going to be a decimal, but we'll be okay. And that's going to equal. Ooh, let's do that. That'd be fun. I don't even know if it's going to work out. But let's have some fun with it. X over Ah, that's not what I want to do. Sorry. Let's do 12x, and then do x over. All right, there we go. Ah, that wouldn't happen. Never mind. Sorry, I'm making up on the fly, y'all. There we go. We'll just do that. All right. So that's our equation. Right now, I can't do anything with it, right? There's no way to solve it until I find a common denominator. So now I'm going to think about my current denominators. What is the least common multiple? Like, what is something that I can make all these go into easily? 12x. Yeah, because can I multiply something by 4 to get 12? Yeah, can I multiply something by 12 to get an x? Yeah. So that's my LCM. So when I look at this, what am I missing by that 12? An x. I'm multiplying the bottom, I'm multiplying the top. This one's missing a 12 because I need it to look like that. And 4x I need to multiply by 3 to get to 12x. This becomes x over 12x plus 24 over 12x equals 9 over 12x. Okay. Oh, it actually worked out way better than I thought it would. All right. Once the bottoms are all the same, what can I do with the tops? Just write it out. So I get x equals, what, negative 15? Does negative 15 work in here? Can I do 12 times negative 15? And it's not 0? So we're good. We're done. It worked. That's wild. A few things of note that are important that actually don't show up in the book on this, but might show up in your homework. What happens if I go and solve a problem? What if I solve a problem, but there's like no end to it, like I do something like 2x plus 12 equals 2x minus 3. Subtract my 2x's over, I get 12 equals negative 3. You guys remember that? You end up with something that is untrue. Is there anything I can plug into this that will make it true? Is there any solutions? No. So that means null set, no solutions. But now, when you go use the computer to plug it in, it's going to say you put in NS, which means no solution. Okay? So again, if you get an untrue statement, that means there's nothing I can plug in to ever make that true. If that's true, there's no solutions. Now, if I have something like 3x minus 2 equals, I'm going to make it really, 3x minus 2, and when you get done, you get something like negative 2 equals negative 2. What does that actually mean? It means no infinite solutions. No matter what I plug in here, it will always be true, right? I could plug in 1,000. I could plug in E. Yeah, and it'd still be true. So this one is going to be infinite solutions. Now, on the computer machine, is there a way to plug in this button? Not really. So what you do is you put R, which means all real numbers. And it says that in the directions as well. So R means the set of all the real numbers because it works for all real numbers, especially. So that's 2.2a. Questions, comments, and or concerns? All right. The next one's going to be pretty quick. Oh, no, I didn't erase that. All right, go ahead and we're going to go in order and do 2.1. 2.1. We're going to talk about coordinate plane. Ooh, should I be? All right. So on the coordinate plane, some quick terminology. What do we call this point right here? Yes, sir. 0, 0 is called the origin. Anytime you hear origin, we're talking about 0, 0. Quadrants. What are my quadrants of this beast? That's 1. Why is that one 1? Why isn't this one 1? Or this one 1? This one 1? It's positive, positive. And then if anyone ends up, well, next semester when we do a little bit of pre-calc, a little bit trig, unit circle, all angles start here and they go that way is actually where angles start in math land. In math land. And then on clocks, they start here. And for ships, they actually start north as well and then go the other way. But we start here. Now, if all angles go this way, when we actually go into math, that's why we go from 1 to 2 is over here. Okay? Then 3, and then 4. This one's negative, positive. Negative, negative. Right? And then positive, negative. And that's it. That's the coordinate plane. You got how many examples do you guys want to do of graphing? All right. Give me a second. I'm gonna get out my magic boards here so I can actually look good at my graph. Time to get out of here. Oh, we got lots of time. Fancy. Oh, and just a reminder now, you can do homework 1. You should have all the tools necessary. How many times they're allowed to retake each homework? 1. What are you allowed to use on the homework? Hey. Technically not wrong. What can't you use on the test, though? Those are both true. All right, we'll figure this out. Watch this magic, guys. This is a life hack. I'm going to put this on Tic Tac. I'm going to make a Tic Tac about life hacks. Well, it kind of worked. This is riveting stuff. I'm going to edit this out and make it look better. I did yesterday. Not long. Probably. Why? All right. So let's graph some points. Where's the point? -2, 1. What's that first value give me? My x. Just a reminder, this is your x-axis. This is your y-axis. So -2 tells me I go left 2. The +1 says I go up 1. How many times have you guys graphed like a Christmas tree or a pumpkin or something like that? What? All right, I think we're good. All right. So now I'm going to keep this up for now, but I want to talk about a type of question you might get asked, some verbiage you might see. So if I give you y equals 2x minus 3, I don't. A question I've seen the homeworks on SATs is questions like, is like -4, 1 a solution? to this equation. Now we talked about it. This is why we don't go in order. We go 2.2a because that talks about solutions to 2.1 that asks what is a solution. How would you be able to tell if that's a solution? You plug it in. You evaluate it. All right, so we do 2 times -4 is -8 minus 3. Is that a solution to that graph, to that equation? No. Would that point be on the graph of it then? No. So like if I was using Desmos and I graph it, I could just look at the graph and say, is that point on it? And it would not be. All right? So that's a type of question you're going to see. If I make that positive for it, does work. Oh, it doesn't. That doesn't work either. Either one works. All right. Let's talk about how to graph by plotting. Graphing by plotting is not my favorite thing to do in the world. So I'm going to show you guys how to do it by plotting. And then the more important thing is I'm going to have you guys bust out a graphing calculator, and I'm going to make sure that y'all can graph on that effectively and find your intercepts on it as well, because that's going to be more important in the grand scheme. So just a quick reminder, if you are graphing by plotting, you start by making your t-table, Mr. T-table. Now, with a linear function, what I usually do, don't tell us that. I usually use 3 points. A lot of people suggest 5. I'm going to do -1, 0, and 1. And I'm going to tell you why I use 3. It's my woodworking principle, right? If you have ever broken down a sheet of plywood, if you make 2 measurements and then draw a line there, is there a chance it will not be parallel to your side? Yeah, because you could be a little bit off on one. If you do 3 points and try to connect it, that's way more accurate, right? And then if you do 3 points, you'll know if one is off. Does that make sense? So never 2, 3 at least when you plot lines. 3 is the least you should do. That includes if you're ever breaking down plywood. And it doesn't matter if you're bad with a skill saw, it's gonna look bad anyways, trust me. Not that I know. So then I just plug in these x values, right? Just plug them in. And then we plot our points. So I have the point -1, -5. Left -1, down 1, 2, 3, 4, 5. 0, -1, 2, 3. And 1, -1. Oh, good. So when I go to draw this, they're all going to be in line. Oh, if y'all ever want, when we're doing like graphs, there is graph paper over in that box. You guys like using graph paper when we do this because we will do a lot of things with graphs. Oh, oopsie, oopsie, oopsie. What did I do wrong here? That's not a dash line. That's not a dash line. We're almost done. All right, let's plot another one. We'll use a different color. What if it's not linear? Mamma mia. What if it's like x squared plus 2? Now, for this one, how do I know what points to pick? You're going to have to find the vertex and other such things. You guys probably -b/2a. But for today, we're just going to say, hey, let's just plot points, make sure we know how to plug it in. This is an intro to it. Remember, plug it in parentheses. This is a good reminder of evaluating expressions. -1 squared is 1 plus 2 is 3. 0 plus 2 is 2. And 1 squared plus 2 is 3. So 3, 2, 3. I go negative 1, 3, 0, 2, 1, 3. And if you remember, quadratics look like this. And again, we're going to hit quadratics harder later. This is sort of an intro to graphing, plugging in things. Are we good? Any questions on graphing using a t-table? All right, then we're right on time. What does it mean? And then I'll show you on the calculator if there's time. All right. What does it mean to be an x-intercept? What does it actually mean, like on a graph, to be an x-intercept? Yeah, exactly. So now here's the thing that throws people off. If you're crossing the x-axis, what is your y value? Or what's your x value? Whatever. It could be anything, right? It could cross at any point on this axis. But what's your y value going to be? 0. Your y value is always 0 at your x-axis. And that's going to be how we find them, okay? So it's always going to be some point x 0, right? Always. Where, okay, so this is my big, if you take pre-calc, if you ever get the question where something occurs, it's your x value. What it is your y value. If you want the x-intercept, you are looking at a point. The x-intercept is a point. Where it occurs is the x. You would never be asked what it is because it's assumed 0. So that means your y-intercept's everything in reverse. It crosses the y-axis. And when you cross the y-axis, you could be anything, but x has to be 0. Okay? So now, you can graph these and find them out, right? But I've always found the best way to find the x and y-intercept is you just plug in y equals 0, or you just plug in x equals 0, you solve for the other one, and you have your intercepts. Now, if you're drawing a graph, if you have 2 intercepts, that give you a pretty good idea what your graph's going to look like? Yeah. Let's do one. I'm going to leave this up, though. I like it. Are we good on this? All right, let's find the intercepts. Guessing it'll be from, never mind, I can't say that. Hold on. From Cass City. All right. Find the intercepts without graphing. Of something like y equals 4x minus 2. All right. So some of you might be saying, oh, I know the one-intercept is going to be negative 2 because I was always taught that is your y-intercept. But why is that your y-intercept? Good question. So to find my x-intercept, I'm going to set y equal to 0. They're always opposite, right? So for my x-intercept, I'm going to say 0 equals 4x minus 2. And then solve it. You might have done this with quadratics sometime in your life. I got x equals a half. So that means that x-intercept is 1/2, comma 0. X-intercept set y equals 0. And then solve it. And then for my y-intercept, I'm going to set which one equals 0? X. So this is why that y equals mx plus b, why you're always like the b is the y-intercept, because when you plug in 0 for x, you just get left with this. It'll work every time. And there's your intercepts. All right, so will everything we ever do have an x and a y-intercept? Like, will every graph we look at this year have an x and a y? What do you guys think? No. Not all graphs have an x and or, I wrote that wrong way, y-intercept. Some have neither, right? Some graphs will have none. For example, look at this one. Does this quadratic have an x-intercept? Does it ever cross that x-axis? No. This is one of those ones where if I plug in y is 0, there's no solutions. Do you remember when you did some quadratic equations back in the day or tried to factor and it was impossible? But I do have an x-intercept, but I do not have a y-intercept, right? Did I say that wrongly? I do not have an x, but I have a y. My y is right there. All right? So let's try. Let's do one more, but we're going to do it on a graph. Sound good? So if you guys want, what time is it? My clock is wrong. How much time we get? Perfect. So what I'm going to do is I'm going to bust out my graphing calculator. If you guys want to grab one, go for it. I know we only have 5 minutes, but it might be worth it. I'm going to show you guys how to find your x and y intercepts using a calculator. Oh, this doesn't have my graphing calculator. Never mind. Never mind. I'm just kidding. I just realized we got new computers. I don't have my graphing calculator app, but I can show you on Desmos for the time being. My bad. They actually, you know what? Not right this second. I'll show you guys. Yeah, I do. I got all the mods. I'll show you on Desmos, which, by the way, you guys have all used Desmos now, right? So on your homework and stuff, can you use Desmos? 100%. In fact, I'd recommend it. Desmos is going to be better than your graphing calculator. I actually really like Desmos for this sort of dealio. Yep. X. Yeah, I am. Yeah.
I'm pretty sure that when I put an S I'm pretty sure like said that it wasn't still there and it marked it wrong. Or at least it would say that. I'm not sure I did.
All right. Here we go. So let's say I'm on Desmos. And I have this equation. So it's a quadratic. My suggestion to y'all is, and this is going to, if you go further on in math or anything, when you're given quadratics, a lot of times go to tech. Now, could I have solved this without using a calculator? Yeah, I could have. I could have factored it. I could have plugged in my points I need. But the big thing is with this is my x, where am I going to find my x-intercepts on this graph? I guess that's the big question is which ones are my x-intercepts on a graph like this? Is it this one or these ones? Yeah. The x-intercepts are where it crosses the x-axis. So remember, what did you call those with quadratics? Yes, those are the solutions of a quadratic, are your x-intercepts. So when I look at that graph, where does this one cross? -5. So one x-intercept is -5, 0. Now I have two x-intercepts, right? What's the most amount of x-intercepts a graph can have? Infinite, right? Yeah, some will go and oscillate forever. So that one's 2, 0. So make sure that if I give you, or if you put in something into a calculator or on Desmos, you can identify the graphs.
Just a quick reminder that we have a brief meeting for tech center students in the high school library with myself and Mrs. Rosenbluth. We're going to start at when? about 10 minutes. Thank you.
Yeah. All right. So for my y-intercept, when I look at this graph, where does it cross the y-axis? -10. Am I going to write -10 as the y-intercept? No, because the y-intercept is a point. It's 0, -10. Sound good? And that's it. We are on pace. We did it. Nice job, guys.